If you had to draw the actual color of the sun, what color would it be? Red, yellow, possibly orange? For something that's in the sky all day long and plays such a huge part in our lives, most of us know so little about it. Our sun is just an average star, with others ranging 1/10 to 10,000 times larger, 3/10 to just under 9 times hotter. Their color is directly related to their temperature. Hottest ones tend to be blue, coolest ones red. Our sun's actual color is off-white with a temperature of 5,800 degrees Kelvin, which is roughly 10,000 degrees Fahrenheit. Today I would like to give a brief timeline of the life of our sun and touch just a little bit on the impact it has on our planet. Everything has to start from somewhere. For our sun, that's in a cloud of dust. The molecular cloud, the assembly plant of a star. It's a very massive cloud of molecular gas and interstellar dust. What turns on this assembly plant is a disruption of a cloud from an outside source, which triggers a gravitational shift. The materials start collapsing in clumps and start to form a ball in the center. In approximately 100,000 years, with the cloud's rotation around the center, a solar nebula is formed. While the star is still forming in the center, now large enough to be classified as a protostar, some of the larger clump formations on the outside are still growing, with some of them growing into very popular bodies. So popular we gave them names, one being Planet Earth. With the continuous growth of the protostar, the extreme temperature and pressure at its core ignite thermonuclear fusion. A wildly active star is formed. They call this star a T Tauri star. After a few million years, the fusion and mass balance out, stabilizing it into a very stable star and well-functioning star. $4.6 billion years later brings us to current day. Our sun is currently in its main sequence, which is its longest phase. The sun's energy is produced by nuclear fusion, converting helium into hydrogen. This is the light you see in the day, the warmth you feel on a warm summer's day. As the fusion continues, greater amounts of hydrogen are converted to helium, which is building in its core. Problem is, as the greater amounts of helium build up, it consumes hydrogen at an increasingly accelerated pace. What remains at its core is a large buildup of helium ash. The helium ash core collapses and its outer layers of the sun swell. How large do they swell? They swell large enough to engulf the orbit of Mercury, Venus, and possibly the Earth. This forms a red giant. Earth will be severely scorched with 100% extinction. With a lack of hydrogen, the sun begins to burn helium as its fuel, which forms carbon. This process lasts for 100 million years until the helium runs low and the shell becomes unstable. The sun pulses violently and blows off its atmosphere in space, which is known as a planetary nebula. Nothing is left except for the core of carbon. This leads us to the final stage, the white dwarf. According to the universe today, the white dwarf is an Earth-sized diamond with a mass of a star. It will lightly shine from thermal radiation, but will no longer generate solar fusion. It will take 1 trillion years, but eventually it will cool to just above absolute zero. From its formation in the solar nebula to its white dwarf stage, the sun will have roughly lived 10 to 12 billion years. It would have helped stage and support life on Earth and ultimately lead to its destruction. I would like to end with a quote from Nikola Tesla. "The sun is the past, the Earth is the present, the moon is the future. From incandescent mass we have originated, and into a frozen mass we shall turn."